In our previous video, we have completed the geometry part and mesh part. Now I will set up the next part. First one, so I will select 4. It depends on your processor type, processor cores. Then start. You can see this window. This is setup window. Okay, done. You can see this is our outlet, and this is our inlet. Sorry, this is our inlet, and this is our outlet. Red color and blue color, and this is our walls. I will click check. Checking mesh done. Okay, here is 1, 2, 3, 4, 5. Main 5 steps. First, I will start from the setup. Models. As we are working with fluid, I will select viscous, then change it to K epsilon, and here you can see K epsilon model standard RNG realizable. Okay, done. Then material, fluid, double click on air. Okay, this is density and this is viscosity. You can change the density and viscosity by your own, as this is not mandatory for me, so I will not change the density and viscosity. But if you need, you can change the density and viscosity from this option. Then click change and then close. Now boundary condition, inlet, outlet, wall. Here you can see the velocity specification method, magnitude normal to boundary, but it is a good practice to use the components, x component, y component. For example, for x component, x velocity, you will use velocity into cos theta, and for y velocity, you will use your velocity into sine theta. But if you don't need this, then you can just take one velocity, no need to components like x component to y component. You just give the value just like 30. This means 30 millimeter per second. Change it. Okay, I will change in our next video and show you with the change of angle how velocity acts. Let's apply and close. Inlet, click on outlet. It will be pressure outlet, and the gas pressure is 0. Here the pressure should be 0, so I will not change it. And now here you can see reference value. Compute from inlet, outlet, airfoil, surface body. We will select inlet. Okay, no need to change this. Then report definitions. Now click new, force report. We are going to calculate drag force and lift force. Also we can calculate the coefficient of drag and lift. So at first click on drag. Okay, now here you can see report output type, drag coefficient, drag force. For let named the drag. Okay, this means I need drag force and select the airfoil. Remember, you need to select it. Then okay, drag force, again force report, drag. Now I need coefficient, so CD, coefficient of drag, and drag coefficient is already selected, so I don't need to change it. Now again select the airfoil. Okay, done. CD and drag. Now I will do lift force, CL, coefficient of lift, again select the airfoil. Okay, you can see this is very easy. Lift. Now you want to calculate, find the lift force, so select lift force and lift. Okay, select it. Okay, now you can see report definitions, coefficient of drag, coefficient of lift, drag force, lift force, close. Report definition has completed. Now residual. By default, the residual is 0.001. For your faster calculation, you can change it to 1e minus 6. For every, I have changed the all the hello. Okay, done. Now initialization, you need to initialize. Here you can see hybrid initialization, standard initialize, working. Now go to run calculation, double click. Here you can see number of iteration. I will select 1000, that it will repeat it thousands time. Click calculate. You can see the graph, lift report, coefficient of lift, coefficient of drag, drag, scale, calculating. Okay, calculation complete. Now I want to see our drag force for velocity 30. I have selected the velocity 30 meter per second. Now I want to, what is our drag? Let's at first lift, compute. Here you can see lift force is 165 Newton, coefficient of lift 0.30, coefficient of drag 0.015, drag force 8.81 Newton. So our setup step is completed. Here you can see geometry, mesh, setup, solution. 4 parts has been completed. In our next video, I will show how to demonstrate the results part.